Can you see now?
Yes, sir.
Okay, so we till last time we have completed how to use the PCA tables for rectangular and circular tanks. Okay, so on the with this, that is the one one of the approach or one of the hand calculation method that you can use for analysis and design of the tanks. Okay, so till now we have just completed the analysis part, because the design part will be same for everything, whether you go for with hand calculation or stat. Ultimately what we are extracting, the bending forces, the shear forces, moments, deflection, those things we are trying to extract from our analysis method, different methods, whether it is a hand calculation or stat. So like from today we will start the FEM model, FEM analysis of the time. Okay, so we are using STAD as a software for the FEM finite element method, for the analysis of a tank, whether it is a rectangular or a circular, or yes, correct, rectangular or circular. Okay, so so what I did, so I tried to break it down in 9 different steps for the FEM analysis of the tank. So the first step is we need to create a model. Okay, so we need to create a model of the tank. After that, second step is we have to define the different element properties. Okay, how you can define, you know, that thumb rule. By using that thumb rule, you can tentatively estimate, or you can tentatively guess the sizes of the different elements, whether it is a wall, base slab, top slab, and if it is subjected to the uplift force, just quickly check manually. And if it is okay, then you can define the different element properties of the STAD. Okay, once those are done, next will be you have to apply the different supports. Okay, once everything is done, so you have to conduct a few ready-made available commands or checks from the STAD. Okay, STAD provide different types of check, so we have to just cross verify though our model is satisfies those. So if those are good, then we can definitely move on. If not, then again we need to just look back to our STAD model and uh, update that. Okay, after that we have to apply the different loads in our STAD model. Okay, we before that we have to manually calculate it. We have manually calculate the different types of load, just we did for the PCA tables. And in any method, it is but obvious that you have to be ready with all your loadings that needs to be applied in the STAD, or you need to use those loads in your hand calculations. So it's mandatory. Okay, so once your application of loads are done, so next step will be you have to create some different load combination based on whichever code that you are using. Okay, once that is also done, so just go and analyze your entire tank. Once it is done, first step will be check the deflection. Okay, if everything is good in terms of deflection, go for result extraction. Result extraction means whether it is bending moment, shear force, uh, tension, whatever it's bearing pressure check. So if deflection is fail, again just go back, change your thicknesses and repeat everything and check whether deflection check is okay or not. Okay, so these are basically few major steps that we need to be follow for FEM analysis of the any tank, like water, circular, rectangular. Okay, all good.
Yes, sir.
Do you know STAD, how to use the STAD? I hope you
Yes, sir.
all of you know how to use the STAD.
Yes, sir.
So based on that, I will not directly go in the basics. Okay, maybe I can just start creating the geometry. Or if anyone who don't know some of the basic things of STAD, maybe I can quickly start on that also. Okay, so I believe yes, you are well familiar with the STAD. So maybe we can directly create the model. Okay, so you know this example we already taken for our PC tables. So same example that we will consider for STAD model. So our internal length of the wall is 12 meter, width of the wall is 8 meter, a wall thickness is zero point 0.5. So instead, what generally do, we consider length of the wall panels from center to center. Okay, so what will be the length of the long wall? So that will be 12 plus 0.25 on each side. So that comes to the 12.5 meter. Okay, and width similar basis 8.5. Height also I'm considering half thickness of the base slab and half thickness of the top slab. So 5 meter is a clear height. Zero point 0.3, that is a half thickness of the base slab and half thickness 0.25 for the top slab. Okay, so these are the few dimensions that we need to use for the STAD model. Okay, all good. So I have created one blank STAD file here. So I will just add the coordinates 0, then 12.5. Go to the top view. I will copy this, or maybe I can assign 0, 8.5, 12.5, and 8.5. So these are our 4 center to center points of the tank. Okay. So I will create one 4 noded plate. For base slab, it's fine. Just remember the which direction, like from to create the base plate, I started clockwise from left node onwards. Okay, so just remember that. Now what I need to do, I need to create walls. So for that, I will just copy all the nodes, copy and paste. What is the height? 5.5, 5.55. So in y direction, vertical direction, I just use this 0.55. Or even I can directly copy this plate also. Copy 5.55. If I go to in 3D view, now you can see this is the base slab, this is the top slab. Okay. So those slabs are now we have created. Now next, we need to create a wall panels. So for that, we again, because we have all the 4 points everywhere for each wall panel, correct? So again, I selected this 4 noded plate. So I have created one wall panel. So now the most interesting part is like this. So we have to follow the axis for each plate. So can you see this axis y, x, y, z? So what are these axes? These are the global axis. Okay. So do you know what is the difference between global axis and local axis?
Local axis maybe with respect to the drawing support. Global axis is a universal axis.
Yes, like y is always up,
Y is always
z,
up, X is
yes,
horizontal,
yes,
and Z
yes.
is the thickness. Yes.
Yeah. So on the left bottom corner, you can see these are the global axis, x, y, and z. Okay. So now what we did, we create a one wall panel. So it have also, and the local axis will be changed according that we have generate in which direction we have generated the plate. Okay. So we can check that also. So for this wall panel, yes, we can check how. So you can just right click it on and go to the levels. You can see axis, plate orientation. Can you see this? Or one shortcut, shift T also. So if you don't want to go with that long route, shift T. It will become, if you again press it, it will be gone. Shift T. Okay. So for this wall, what are these are the X, Z, and this is the Y. Maybe I will just open only one wall to just avoid the confusion. Select new view. Okay. So can you see the difference between this? This is our global axis, and this axis which is in red, it is local axis for this one plate. Okay. So you can see this Z is exactly opposite to the global axis. Y is parallel to the X axis. And here our vertical is as a X axis. So did you got the difference between the local axis and global axis? How to check? And this will be get changed. It's based on the how we draw the plate. Suppose now you can see X is up, Z is against global Z, and Y is parallel to Z. Suppose right now what I did, I will just started creating the plate using bottom left corner by using anti-clock by using clockwise direction. If I delete this, okay, and I will start somewhere from different thing. Suppose instead of here, I will start from here. You can see again the local axis will be get change. I will just open the new shift T. Can you see this? Now X axis is now get changed. X is parallel to X. Y is exactly opposite to the global axis, and Z is always Z is same. So based on from where you are going to start, it will get changed. Clear? Any doubt between local axis, global axis?
No, sir.
Okay. So again, I will open the model. I will delete this, or maybe we can keep as it is. But for modeling purpose, we must consider that because we have to apply the loads on wall, correct? So if I consider,
Sir, can't we apply the load on this one, the global axis, sir?
yes, we can apply the load on the global axis, but we have different walls, correct? So suppose this is my one wall, or maybe there will be another wall at here, and you want to apply the water load. Okay. So water load means which direction it will be act,
Z. Z.
local or Z, local or global?
Local, sir.
Local,
No, sir. Global. Global, sir. Sorry.
global. Okay.
Yes, sir.
But what about this?
That will be S1, sir. Local.
That will be also local. So
Yes, sir.
every time you have to see, or every time you have to create a different loads. Yes, you can apply, but what happened? So it will take much time. So now this is a very small model. We have only 4 walls. So once you are dealing with 100 walls in your model, so are you able to apply each and each time by selecting each individual wall? So no.
No, sir.
So for
No.
that, so our model is, we should make a model such a way that our local axis will be same for all wall. Okay. So if I want now, if I consider this wall, okay. So if I consider this wall, can you please mute Venugopal? Okay, thank you. So if I consider this wall, okay, or maybe I will copy this as it is. I exactly I will show the problem. I have copied this paste reference point. I have selected this one. Just paste it. Okay. So now I want to select this. I want to select this also. Just go to the new view. Okay. So now for this wall, local local axis, local Z is away. Okay. Correct. Or maybe I will go to the side view. Mhm. So this is side view. We have one wall here. We have another wall here. Okay. So this is the internal side. So we want to apply the water load here. So for this, which direction you are going to apply?
Against Z, sir.
Against local Z. Okay.
Yes, sir.
Means you will provide the minus sign. And for this, your wall, your load will be like this. Correct. So for this wall, what you will do?
Positive load.
Positive. Correct.
Yes.
For
Yes.
this, you have to positive. So now what happen? You have to apply this same value of load 2 times. For this wall, you have to go with minus, and for this wall, you have to go with the plus. So if your global axis for this is like this, so what happen? So in single command, you can apply this load to all walls. Just give me 1 minute. I will just go back and come back. So someone is there. I have to open the door. Just give me 1 second. Okay. So I'm back. So understand the problem. So if like the axes are different for each plate, there are number of load will be more, so it will be take some time. Okay, so just to avoid or to be efficient, if we model those plates such a way that if the internal axis, like for this instance, the z, if the z axis also like this, so then maybe for minus this we can cover. So we can select all walls and provide just minus x, and all loads can be get applied to the wall. Did you understand what I want to say? For all plate, this this axis should be same. Okay, so that's for that what I need to do. I will again go to this. I will delete this plate also. So I will create this plate again. I will start from this. Now this is the Z. Got it? So now Z axis is for both plates are same, but for Y axis it's like a difference. So again this will not also work. Maybe we can just try another option. We need everything same. Is it okay? No, this is not also okay. Is it okay?
Our intention is only to concentrate on Z axis or the X and Y also, sir, local?
Both,
All the three axes.
all the three
Only,
axes.
only the Z axis should be towards the outside of the wall.
Yes,
I mean,
or
directly.
maybe Z axis also be fine. So, but again, that we have to consider all the three axes, two axes also, because bending moment and shear force will be with reference to the local axis. So I'm just trying to find the different options.
Okay, okay.
Sir, if we mirror the plate axis will be same, right?
Yes, you can mirror the also. So axis will be the same. But for that you need to you need center point. So what you can do, you can just take a one beam here. You can insert one node here at midpoint. Okay. So you can select this plate and go to that mirror command. Mirror, select appropriate axis like XY, give the node this one. Okay, but still the axis is not same. We need Z inside, not outside. So this is also not generally what I do. I just start keeping this in front of me, right side positive. Consider always front view elevation and select top right hand corner node first, top. Okay. So if I start with this, let's see how it works. For this also, I will do the same thing. So maybe we can have some uniform things.
What they told is top right, sir. You have selecting the top left, I think.
Always consider front view elevation on the top first right.
Elevation plate.
Yes, first
Point number
node.
2
Yes.
is top right hand corner. Oh,
Yes. So I
that is the
selected this
left.
one.
Right.
Right.
Okay. For the
Okay.
okay.
So intention is like, yes. So Z is same for all plate. Okay. So if I go for this one, I don't need this now. Okay. So for this creating this plate, this will be my right. Okay. Now the Z is also inside the plate. For this, if I go to the elevation mode, this will be my first point. No.
Hello, sir.
Anti-clockwise direction.
So that XY can be in any direction, sir. Only the that should be in the position, sir.
Yeah, XY can be in any position.
Okay, okay. Sir.
Oh, got it.
Because it seems to be in the outside. This is my anti-clock. Yeah. So now you can see all Zs are inside the tank. Okay. Now we can just, we already provided, I guess, the top slab. Yes. So now we are done with all our plate element. But again, I'm going back to this plate orientation. So we just see the plate how to be same as a global system. Tricks: always consider in the front view elevation of the plate. Select top right hand corner first, node first, and select remaining 3 nodes in anti-clockwise direction. Okay, so that we done. So because of that, what we are getting, so Z axis should be same for the all nodes. Okay, next. So now still we have this big huge plate. So generally what we do, so to get better results, we need to divide this entire one plate into some small segments. Okay, so maybe we can get some good results. So there is as such a not a fixed logic, but generally what we do, so you also know that aspect ratio B and A, correct? B means the length of the panel and A means the height of the panel. So most of the time the aspect ratio should be somewhere between 1 to 1, between 1 to 2. Okay, so the thumb rule is like that. So just divide your length of entire length of the wall panel by thickness of the plate. So now we have thickness of the plate is a 0.5, correct? And total length of the wall is 12.5, I think. Where is that? Twelve point five, 8.5, 5.55. So I want to generate a mesh for this entire 12.5 meter wall panel such a way that, so it will be, the aspect ratio of the plate will be somewhere around 1. Okay, between 1 to 2. So what is the thickness? 0.5. So what I will do, 12.5 divided by thickness 0.5. So I need 25 segments in lengthwise, and at the same time the height of the wall is 5.55. So 5.55 divided by 0.5. So 11.1. So maybe I will make as a round figure 11. Okay, so what I will do, I will select this wall panel plate, right click, generate mesh, quadrilateral plate. So you can see this 0.55. So for that segment, I will create 11. Then 12.5, I want 25. Again, same thing, 11, 25. Okay, I don't want this now. You can see this. So if you again measure this aspect ratio, this 0.5, 0.5. So it is almost 1. Okay, so that is most desirable, but it's not hard and fast. That is, it's absolutely 1. So it is okay if it is 0.8, but between 1 and 2 will be most desirable. Okay, so same thing that we need to apply for this wall also. Select this wall, just right click. You need to just remember that figures 25, 11, 25, 11. Okay, now you can select this one. So you know what is the dimension for that. So you can select this one and this one at the same time. But for that, you just know which is the first, the length AB, which is what is the length of the first length. That's why just select generate plate mesh quadrilateral and just see AB, that is a 5.5. So now select this one and this one at the same time. Generate plate. Now you know AB, length of the AB is 5.5. So you can directly just add 11. And now width, that is 8.5 divided by 0.5. 17. We have to provide 17 numbers. 11, 17. Correct. Something is incorrect. That's why it's AB is different because of that axis. So we need to just make separate. Generate plate 5.5, 11, 17, 11, 17. Seventeen, 11, 17, 11. Select top plate, quadrilateral. 8.5 means 17. 12.5 means I think 25, 17, 25. Now your top plate also get meshed into smaller segments. Now only remaining thing is a base slab. So you can just go to the front view, select this base slab, mesh it 17, 25, 17, 25.
एक्सक्यूज मी सर
हम्म?
सर ये मैशिंग किस लिए करी है सर हम लोगों ने सर ये
मैशिंग इसलिए किया हमने, हमको रिजल्ट हम जब एक्सट्रैक्ट करते हैं तो रिजल्ट की जो इंटेंसिटी है वो पता चले. कि कहाँ से कहाँ तक उसका ट्रांसफर हो रहा है. देर आर डिफरेंट थिंग्स. अगर हमने पूरी एक एंटिटी ली तो वी कैनॉट bifurcate the different values for the bending moment. ओके अगर यहाँ मेरी बेंडिंग मोमेंट यहाँ पे 10 आ रही है, यहाँ पे 5 आ रही है, यहाँ पे -30 आ रही है, वहां पे 0 आ रही है, तो ये थोड़ा सा जज करने के लिए वी आर मेक इट इन फाइनर सेगमेंट्स.
ओके सर.
ठीक है,
यस सर.
इसको सेव करते हैं. सो वी आर डन विथ बेसिक बॉक्स. सो नाउ वी नीड टू क्रिएट अ toe for the base slab. Okay, so how to create that toe? So just go to the front view, just select the base slab, make that view only, just go to the, I don't want all the dimensions. So now this is the base slab and our toe is, I think, 0.3 guess. Okay, 0.3 plus half thickness of the wall means 0.3 plus 0.25, 0.3 plus 0.25, so 0.55. So we want this node, copy, just copy this, paste it, minus z 0.55 and minus x 0.55. Got it? So same thing. We want paste this 0.55 minus 0.55. Copy this node 0.55 and what will be the y value for z? Plus or minus? Hmm? It should be plus. Same thing, copy, paste. Now I am using this minus because we are going against the global z. Okay, so now we get all 4 nodes, corners of the toe. Okay, but again we need to copy this, copy x 0.55, copy this minus x 0.55, copy this minus 0.55, copy this to 0.55. Minus. Now again for base slab it's fine, you can draw as per your convenience. So orientation is not that much important because we are applying the loading for the base slab that will be a universally minus or plus, minus which is parallel to y. Okay, so we can just create 4 this plates here. Okay, so now again we need to mesh this. So all the nodes can be matched. So select this one and just generate quadrilateral 12.5 means 25, 1, 25, 1. Okay, same thing for this. 17, 1, 17, 1. 1, 25, 1, 25. 1, 17, 1, 17. Okay, so these nodes are not required. By mistake, I just copy that node to the wrong side. Okay, I just keep as it is. If you now see, you can see this. We have created the entire group. Okay, almost our model is ready. Hmm. So before that, before application of the different element property, it's always good that we can create some group. Group means that groups can help us to selection of the different elements. It help us for application of loads. Okay, so maybe that's why we can create a different groups. So how to create? So shortcut is Control G. So if this window comes and you have to just give the name of the group. Okay, so like base slab, select type plate, because we are dealing with the plates. So base slab, if you provide space, it will not create. The title has blank character in between, so cannot create a group. So you cannot space any blank. You cannot provide any space between. Either you can provide underscore or you can just direct go as it is. So my preference is base underscore slab plate. Okay, it is created. Now just go to the front view and select all the base plates. Okay, if you want to see this in 3D view, yes. So now you have selected all the base plate. Okay, so associate it. Now you, if you want to check that, select this group and press on the highlight. You can see this now all the base plate are highlighted. Okay, so I want to just create that another one group by keeping the same thing. So now I've just created kept only this base plate. Now I want to create one group so I can apply the water load. Okay, so create one more group, water load for base slab plate. That is okay. So now how I can select? So I just select all this top plate. Okay, so except this, everything, all internal plates will be subjected to the water pressure. Okay, so how to select that? So just go to the select view, by inverse plate selection. Correct, just go to that new view. So now you have only these internal plates except two. So select this plate, associate. Just who you want to check, highlight it. Yes, good. So now again create a group for top plate, because you want to apply soil load on the external periphery of the tank. Correct. So how to create that? So toe underscore plate. So for that, how to select quickly? Just select base plate, highlight, new view. Okay. Now select water load. Okay, so the water load is selected. Now just again go back to your select by inverse plate selection. So just again right click. Now you have only the top plates. So select this group, select all this plate and associate it. Now you can see this two plates are selected. You want to just check it again. Base slab, yes, all the plates for the base slab are selected. Water load, yes, internal plates for water load are selected. Toe plate, yes, all the toe plates are now selected. Maybe you can see on from the top view also. Understand?
Yes, sir.
Now we will create one more group for the top slab. Top underscore slab. How to select this? Just go to the front view or side view, select all the plates such a way that only horizontal plate can be get selected. So associate top plate. Now you can create a long wall underscore wall. How to select long walls? So again go to select parallel. There are some tabs in the recent commands, plates which are parallel to the XY. Then fine. This is the quite old version. So that's why that command is not here. So maybe fine. Base slab, select inverse. I don't want top slab also. Select inverse. Okay, so now go to the plan view. So I want to select long walls means I have selected this one. I have selected this one. So these are the two long walls, correct? Associate. Now I want to create a short wall. Select this. Done. So we are done with all the groups. Save. So now we have done with the modeling. The first step is now done. So now next, define the element properties. Okay, how can we define? Just go to the properties. Properties. You can hit on this property page. You will find this dialog box. So in that, since we have only plates, so just click on thickness. Okay. So we have wall thickness of 0.5 meter. Add. We have thickness of the base slab is a 0.6 meter. So add. And we have thickness of the top slab that is a 0.5 meter. So we have already added that. So only two thickness that we need. Okay. So what we will do? So this is for 0.5. Okay. And this is for the base slab. So we will apply thickness of the base slab first. So how to apply? Just go to the group, select base slab, highlight. So keep in the same thing. So you just don't exit from that plate thickness command and just use this button. Select to assign plate and assign. Now these plates are assigned. All the base plate are assigned with the 0.6 meter thickness. Okay. So just go select inverse plate selection. Okay. So now fortunately we have only one wall, only one thickness that is applicable to the all walls and the top slab. So now this, select this top plate. You can see, just verify whether it is 0.5. Yes, it is 0.5. And select manually by dragging this cross window and select all and assign it. Okay. So now this way you have applied, defined different element properties. Okay. Save this. You can see this 3D window rendered view also, where it is that. Can you see this? This is a 3D rendered view. Okay, the next step, applications of support. So which types of support that we need to apply for the tank? I want some answers from you. Yes, Shahaji Patil.
So fixed support,
Fixed support where?
base slab and wall,
Okay, and
top slab and wall,
where?
top slab
Also, sir.
and wall.
Top slab. Okay. Any other support required? No? Okay. So now what happened? Yes. Anybody want to say something?
Corner of walls,
Corner of walls, correct. Okay. So now what happened? So since what we are assuming, walls are fixed. Okay. At it ends and the bottom. Correct. So when we are using the PCA table, what we are understanding, what was our assumption? My one wall panel is fixed at base and fixed at the side. Okay. So here we actually model everything. There is a base slab, there is a side wall. So ideally we don't need to provide any support for wall corner or wall to slab joint because those elements are there. Okay, so ideally we don't need to provide any kind of support. If there is any special requirement that you need to consider, then only in that case maybe we can think. But right now, yes, we don't need to provide any support to the wall to wall joints, to the wall to top slab joints, to the wall to base slab joint. Okay, because based on its stiffness, wall will get transfer the force to the base slab or from top slab to the walls or from wall to another panel of the wall. Okay, जिसकी जितनी कैपेसिटी है उतना वो लोड लेगा, उसके बाद का लोड वो ट्रांसफर करेगा. How it will get transfer? Because one thing I just want to again explain you. So when we have created the different small segments or generate plate mesh, so why we stick with that numbers? So whenever we create different small segments of that 12.5 meter wall, we always put 25 25. Okay, when we go with the 8.5, we always provided 17. If those numbers are not matching, means what happen? These this for instance, this wall to base slab, these nodes are, in that case, if those are different, these nodes will not get matched. Okay, in that case what happen? The load will not get transferred to the base slab, because what happen, now these nodes are the medium through which all the loads will get transferred to the next node. Okay, so if those nodes are not matching, you will get error. Okay, your analysis will not be get performed. So make sure your all nodes should be get matched with the next plate, whether it is a wall, whether it is a base plate, or whether it is a top slab. So that's why I'm saying that that number should be very important. Correct? Okay.
Yes, sir.
So this way we have okay, we are talking about support. So that's why, because of the nodes are matching, we ideally we don't need to provide any support to wall joint, any don't need to provide any support to wall to base joint, and same way. But what happened for the base slab? Because base slab is resting on the soil, correct? It is not a elevated structure. It is a resting on the soil, correct? Whether it is a below ground or on ground, it should be ideally supported to the ground. Understand? So when we analyze the base slab for the from the PCA table, we don't have any special kind of coefficient for the base slab because it is subjected, because it is resting on the soil. Okay. So now what needs to be done? How how we need to consider that soil into our model? This is my slab. This is my wall. You can consider this as a section or maybe front view. Okay. And this is the soil, or maybe you can consider soil as per your convenience. You can consider below ground or where you want. Okay. So entire thing is going to rest on the soil. Okay. So what happens when we are applying some pressure? If we know equal and opposite reaction will be there. Correct? Agree with me?
Yes, sir.
So in short, so there is a soil which is also acting as a some kind of support to the base slab. Okay. So soil also have some kind of stiffness. Soil have some properties. Based on that properties, soil will try to resist or try to absorb whatever the force coming on it. Correct? Maybe it will try to absorb. It will try to resist. Okay. So for that we need to consider that special parameters of the soil or special properties of the soil, such a way that we have to convert it into different kind of support. Okay. So in short, soil will be act as a some kind of spring there. Okay. This is a spring, and it have some stiffness. Okay, whether it is soil or whether it is a soft rock or hard rock, it has some properties. Based on that, it will be give reaction. Okay, it will give reaction to the above load. Okay, then how to find it? Okay, so we want to convert this into support. So for that, we can call as a subgrade modulus of the reaction. Okay, in technical terms, it can be considered as a subgrade modulus of the reaction. Generally, it is given by geotechnical engineer through its soil report. Okay, this value, this subgrade modulus of reaction is given by the geotech engineer. Okay, if it is not, then maybe we need to assume something, but not the values. How to calculate that? Because of this load, what happen? Soil will try to deflect, correct? If you see, if you go to the seashore and if you press that soil, what happen? That wet soil will be try to get deflect. Okay, you can find out your foot impression, correct? So why it happened? Because soil was get deflected, maybe by 100 4 mm, 10 mm, 25 mm, based on the load. Okay, are you getting me?
Yes, sir.
Okay, so if that value is not given, so we need to assume some deflection. Okay, and with that deflection, we can find out the values of subgrade modulus of reaction. Okay, and like for this, what how we can assume the deflection? So we know the deflection criteria is L by 360. So, and our water tank base slab is 8 meter wide, or maybe by considering the thickness, it will be 9 meters. So what will be the maximum deflection for the base slab? 8.5 divided by 360. How much deflection will be allowed for the base slab if we consider L by 360? Can you tell me the answers? So I calculated it as a 23 mm. Okay,
23.61.
correct, 23.61 mm. So that will be the maximum allowable deflection for the base slab. So we got this value. Then what is the next step? Then next step will be the to find the stiffness subgrade modulus. So for that subgrade modulus, there is a one formula. Okay, so this one. How to calculate subgrade modulus, which is generally denoted as a K. K is equal to P divided by S. Okay, and S is allowable deflection. Just now we calculated. And what is the P? P is safe bearing capacity of the soil. Okay, generally it is also given by the geotech engineer. If not, we can find out based on the type of the soil. Okay, whether it is a soft murum, hard murum, soft soil, hard rock. So if that geotech engineer is not provide, we have some ready-made safe bearing capacities of soil in our books also. In strength of material, based on the different types of soil, we can find out the subgrade safe bearing capacity of the soil. Okay, got it?
Yes, sir.
So it's very easy. So once you need to find out first what is the SBC, and you just fix the allowable deflection. So both values are with you. Based on that, you can find out the stiffness. So assume in our case, our safe bearing capacity is 350. Okay, 350 kilonewton per square meter. And we got 23. So assume let's 25. Just make it as a round figure. So what will be the stiffness or subgrade modulus of reaction of the soil? Can you calculate?
15.21.
Something is incorrect. Just check you have properly added, converted your
1 second.
Point eight.
units.
0.875.
No. Or maybe you can consider deflection as a 20 mm instead of 25. So don't go
Atta.
beyond that limit. So just below that limit. Instead of 23, consider 20.
2070.
How much? 17.5. Unit is incorrect. What is the answer? 17.5. 17,500 we should get. So you have to convert this 20 mm into meter because it's in meter. Okay. Or either way, you have to convert those into square meter to square mm. Okay, that's why what I did, 20 divided by 1000. So that's why I'm getting 0.02 meter deflection. Now 350 divided by 0.02. So that's why I'm getting 17,500 kilonewton per square meter. Okay. So this way we get the soil stiffness. So how to apply now? So just go to the support page. You will get this dialog box. Go to the create. You can see there are different tabs. So in that you have to go to the foundation. Click on foundation. Use the plate mat because we have created a plate. Okay. Plate mat. Why? Because we want to apply this soil in y direction, and now provide this 17,500 this value here and add. So now you can see this, your support is there. So now how to assign? So it should be assigned to all base plate, correct? So that's why, that is the beauty of the groups. So just go to your groups, select this base slab group, highlight. So just stay in this selection mode for the support. You just verify whether it is selected in proper way. You don't click on this assign to view. You should be assign to selected plates because those are selected, and just assign it. Now you can see this. The stiffness of that soil is now we have assigned in terms of that support. Okay. Understand?
Yes, sir.
Okay, just save this. So now what is the next step? So we have assigned supports. So we are done with this all first four. So now there are some different checks. How to check that? Okay. So I have
What
intentionally
about the side walls, sir?
Hmm?
Side walls.
Side walls for that.
Side walls, no support conditions to be required, sir.
No, because side walls are held in proper position with this other two directional walls.
Okay. Okay.
Correct?
Okay. Yes, sir.
Okay. So I don't want to see this support also. So I have intentionally kept these nodes which are not used because I want to see this checks. So now next step is checks. To go to the tools, check multiple structures. One structure, okay. So if there is a other structure, it will be show as a 2. So make sure that you have only one structure. Sometimes it's a project demand, so it's fine if two structure, but generally it should be one. Means your all entities are attached to either each other. Okay, there is a no gap or no fine gap between two elements. So next, duplicate nodes. Check this. Maybe you can just add some tolerance. 1 and 5. These are the two duplicate nodes. So maybe you can merge it. Delete first, anyone. Yes. So now duplicate nodes are gone. Okay. So these are some errors that can be happen during the modeling of the structure. So we are just create duplicate nodes, duplicate plates. We don't have members. That's why I'm not selecting this. Duplicate plates. No duplicate plates are found. That's fine. Perfectly fine. Go again, tools, orphan nodes. Highlight. Maybe can you see this, which is now highlighted here? So we don't want this, because if we go with this, so we will get errors during analysis. So now we just know that orphan nodes are there. So we can delete by just pressing this delete button, or maybe you can just select orphan nodes and remove. So it will automatically get removed. So can you see this? So there are no orphan nodes now in our model. Okay. So now next step, check for wrap plates. Maybe you can select all. No overlapping plates. Check for wrap plates. We have taken this overlapping plate. Suppose if there is any plate which is overlapping, so that can be also get detected through these checks. Okay. So no overlapping plates are found. So is there any other checks are pending? No. We are done with all the most of the checks. No. There are few more checks are pending. Select by missing attributes. So we may, before analysis, we need to just check this also. If there is any property which is not assigned, like missing property, no entity with missing property is found. That's fine. Select missing elasticity. No, it is fine. Select missing density. No. Once we applied a material, so it will be all automatically take care of that. But still, you have to perform these checks. Otherwise, during analysis, you will get some error. Missing alpha, those are not required. But yes, so this way we have conducted most of the checks that is required for the our structure. Okay. So now up to this we are done. So now next step, application of loads. How to apply? Okay. Just go to the loading. Go to the load page. Select load case. Add. Type dead load. Just number as a 1. That is fine. Dead load. I will just write as a short form. Dead load. I will add this. Then live load. For that I will just add L. Save. Then fluid load. For that I will add F. Then soil load. For that I will add H. Okay. So we have created different loads. Okay. Now we want to add actual loads into that. Okay. Under dead load, what will be there? Self weight. Okay. Just select dead load, add self weight of the structure with -1. Okay. So now it is applied to automatically apply everywhere. Now live load. So maybe we can consider some 3 kilonewton per meter square live load on the top of the tank. So just go add live load. So which load we can select? We can select plate loads. Okay, -3. Direction global Y. That's why we have added minus. Okay.
Okay, how we can apply this? Select this load, open our groups, Control G, select this load, select top plate, top slab. Okay, assign, highlight, and then select this and assign to selected plates. So now your live load is assigned to top slab. Okay, now fluid load. We want to add fluid load. So what is the intensity of the pressure? 5 meter was the internal water height. So just go with only test condition. Full tank is fully filled. Okay, 5 meter means 50 kilonewton per meter, which is a triangular force. Okay, so for that, how we can assign? Go to this fluid load, plate load, select plate loads. Under that, there are different options. So under that, select hydrostatic pressure. Okay, now select plates. How to select? Just go to the front view. Except top and base plate, you can select all the plates. Just make sure that you have not selected top slab and bottom slab. Yes. So why we can select all the plate at a time? Because our local Z axis is in same direction. Okay, which is acting either away or towards the load. Okay, that's why I have selected all the plates. But for that, I should know what is the local axis. So what I will do, I will just select one plate, click on the new view. So now I can know whether I need to want to plus or minus. So I click on Shift T. Okay. So my water load is acting against local Z. Okay. That's why I need to put minus value. Okay. So again, I want to select auto fluid load, plate load, hydrostatic load, select plates, go to the front view. I have selected all the plates except base and top slab. Done. Now you can see different parameters are there. So we will start. Interpolate along global axis. Which axis? So it is always Y. So select Y. So now we are just checked local axis Z. So direction of pressure, which will be there? It will be local Z. Okay. Now you can see this value W1 and W2. Okay. So W1 will be at the bottom. So that's why it will be minus 50. And at top, it will be 0. Just add it. It will take some time. Yes. How to check whether it is correctly applied or not? So for that, maybe you can select only one wall panel. So this is quite important. We need to make sure that our load is applied properly. Can you see this? It is applied properly. You can go and load values also. I don't know why it's not visible, but in your STAAD model, you can easily see that values. Can you see properly? It is applied correctly from inside to outside, triangular shape. Okay, got it? So in single command, we have applied load to all walls. That is the beauty, or that is the very much important while creating the plate. So such a way that we need to focus on its local coordinates. So our work will be get little bit easy. Definitely you can create plate any as per you want, But if that axis will be different, then you have to apply load that multiple times. So in our case, we have 4 walls, so you have to apply this exercise 4 times for long wall, for again one more second long wall, for first short wall, and again for the second short wall. Understand what I want to say? Okay, so now we will apply soil load acting from the outside, and that was a 55. Soil load, trapezoidal load, hydrostatic load. Select plate, again go to the front view, select all the plate except top and base slab. Done. Interpolate along Y, local axis Z, that is fine. So now soil load and local Z will be acting in same direction. So I am not adding minus. So instead of minus, I'm just putting 55, 0, that is correct. Add. It will take some time. Yes, close. Now you can see. Can you see this? Soil load is applied from outside face. The application of force is towards inside, correct? This is a front view. Maybe you can check from the side view also. Got it? Now again, we need to add surcharge also. So this is only the triangular pressure of the soil. So surcharge, how to apply surcharge? Again, stay in that same load case, add plate load. So now we don't need to add select hydrostatic because it's a uniformly distributed load. Okay, that's why use the plate pressure on the full plate. Okay, so that what is the value of that? It's a 10. Okay, it's a 10 local Z. Okay, add. Go to the front view or maybe side view also fine. Select all plates and apply to the assigned to selected plates. Now the surcharge will be applied to all plates from the external side. Got it?
Yes,
Okay
sir.
now?
Hmm.
Okay.
Yes, sir.
So this way we have done with all the loadings. Now what is the next step? Next step will be the load combination. So just go add load combination. Okay. So for me, I always start with the 100 number for service level. Means dead plus live plus fluid. That will be one case. Correct. Means tank is full. No soil. So that's why I have intentionally not selected H. Correct. Dead load will be always there. Live load also there. Fluid load be also there. Factor 111 without factor. Okay. Add. So now next step will be tank empty. That's why I'm considering 101. Why 100? That's why I can differentiate between load case and load combinations. My load cases are start with 1, 2, 3, 4 up to n numbers, and my load cases will be start from 100 numbers. Okay, 101. In this case, what I will do, dead plus live load can be also possible, plus soil load. Tank is empty. That's why I have not added fluid load. Okay, dead plus live plus soil. 111 purely unfactored. Okay, so this is my another case. Now I will go with the factored. So how to differentiate between the service level and load combination? So that is my practice. So instead of 100, I am starting with 200. Okay. So maybe some kind of 1.4D plus 1.4L plus 1.4F. So again select dead load plus live load plus water load. Change the factor 1.4, 1.4, 1.4. Add. Next, tank empty 201. 1.2 D plus 1.6 L plus 1.6 H. So I'm choosing the factors as per my convenience. So select dead load plus live load plus soil load. What is the factor for dead load? 1.2, 1.6, 1.6. Okay. Now for uplift. For that, maybe I will consider as a 300. Uplift. So for uplift, which load will be there? Only dead load, correct? And
So load combinations, do we have a particular setup or?
no, you have to stick with the IS code, which code that you are using. Suppose you are using IS codes, so based on that you have to use.
These factors and everything are written in IS codes, sir.
Yes, there are different types of load combinations which is readily available, so you have to just use that one only if you are following that. Because this load combination I'm used to with those are as per the US American standards. So I'm most from last more than 10 to 15 years I'm working with the US code, not with IS code. So I'm little bit aware during the academics, but I'm more but like these are only just factors. So based on IS code you have to just change instead of 1.2 to whichever factor that you want. Okay.
Okay.
Uplift. So we miss one load case here. Add fluid uplift. So what is the uplift force? Anyone can calculate based on this? Suppose our groundwater is up to the top of that top slab. So what will be the uplift pressure on the tank? We have 0.5 thick top slab, we have 0.6 thick bottom slab. You can try. So what is the total height of the water above bottom slab? So thickness of the bottom slab is 0.6. Okay, then clear height is 0.5 plus thickness of the top slab, that is 0.5. So what is the height of water above bottom slab? That is 6.1 into density of the water, that is a 10. So 61 kilonewton per meter square will be our uplift force. Okay, so I have to apply this force. Add plate loads, correct? 61. Did you get how I calculated this? This is acting upward, so that's why I have not added negative. It is acting towards global Y. Add. Where to apply this? Select this load. Go to your groups. Select base slab. Highlight. Stay in selection mode. Assign to selected plates. Assign. Just go to your front view. You can see this. Now uplift pressure is applied to the base slab. Okay. Now go to your load combination. Load combination 300. Up, lift. So what are the forces that we need to? Obviously, dead load and uplift. So by universally, we cannot consider 1 as a factor for dead load. We consider as a 0.9. We are intentionally reduce the self-weight of the structure, and we are increasing the force 1.2. Got it? Add. Yes. So now we have all our load combinations are ready with us. So up to the step number 6, we have covered everything today. Maybe we will stop here today, and in next session maybe we can cover the remaining 3 steps. Okay, so before closing, any questions? Maybe you can try at your end for this water tank, rectangular water tank. If any questions, let me know. Maybe then we can discuss it. Okay. Okay, all good then. So we will meet again in next session.
Okay, sir.
Okay, good night.
Thank you, sir.
Thank you, sir. Good night, sir.